Overview of Jacques Sarfatti's provisional patent. Jacques Sarfatti, a theoretical physicist known for his work at the intersections of quantum mechanics, general relativity, and advanced materials, filed U.S. Provisional Patent Application No. 63/892-398 on October 2, 2025, with the United States Patent and Trademark Office, USPTO. Titled Approximately Room Temperature Spintronic Implementation of the Josephson Tunneling Junction for Fully Conscious AI Post-Quantum Computer Technology, the patent describes a novel device that replicates the key functionality of a traditional Josephson junction used in superconducting quantum computers at ambient, room, temperatures without requiring cryogenic cooling. Technical explanation. Traditional Josephson junctions, these are the backbone of current quantum computing hardware, e.g., as recognized in the 2025 Nobel Prize in Physics for cryogenic qubit advancements. They consist of two superconductors separated by a thin insulating barrier, enabling coherent tunneling of Cooper paired electrons, via the AC Josephson effect. This produces phase-coherent oscillations, frequency. Bold italic F equals bold 2 bold italic E bold italic cap V over bold italic HF equals 2 electron volts /H. Where E is the electron charge, 5 is voltage bias, and H is Planck's constant, essential for maintaining qubit superposition and entanglement. However, they demand extreme cooling, below 1 K, to suppress thermal noise, limiting scalability to massive, energy-hungry data centers. Sarfatti's innovation, the patent proposes a spintronic analog using magnon, spinwave, Bose-Einstein condensates, BECs, in non-equilibrium metamaterials such as yttrium iron garnet, YIG, films or ferromagnetic/antiferromagnetic heterostructures. Key elements include flow-K pumping, periodic microwave driving, 10 GHz, creates time-periodic flow-K states, inducing coherent spin-polarized magnon currents that mimic Cooper pair tunneling. Resistively shunted junction, RSJ, model adaptation, simulations, e.g., by researcher Christian G. Barker, show stable, bias-dependent gigahertz oscillations with phase locking, achieving 96% coherence fidelity at 300 K, far exceeding cryogenic baselines without decoherence from thermal vibrations. Dipolar and topological enhancements, incorporates skyrmions/anti-skyrmions for tunable barriers and spin-orbit torque, SOT, for low-power control, enabling error rates below bold 1 bold 0 to the minus bold 4 and superscript 10 -4. This builds on experimental precedents like the 2021 Physical Review B paper by Kreil et al., which observed room temperature AC Josephson oscillations in YIG magnon BECs, but Sarfatti's filing is the first to apply it practically to scalable qubits. The provisional status secures a priority date for 12 months, allowing refinement before a full non-provisional filing. While details remain confidential, Sarfatti has shared excerpts via x&academia.edu, including RSJ model simulations confirming stable, bounded dynamics akin to Prigoghine's dissipative structures, implications if confirmed in laboratory tests, laboratory validation via metrics like millisecond coherence times at room temperature and sub 10 -4. Error rates would eliminate the cryogenic barrier, enabling chip-scale quantum processors. This could integrate into everyday devices. Mobile quantum computers and iPhones, on-device qubits for real-time quantum-optimized tasks, such as unbreakable quantum key distribution, QKD, encryption, personalized molecular simulations for health apps, e.g., instant drug interaction predictions, or edge AI with conscious emergent properties. Sarfatti's claim of qualia from entangled spins, though speculative and ethically fraught. Quantum computing in Tesla electric cars, in-vehicle processors for hyper-optimized autonomous driving, solving NP-hard traffic routing, battery chemistry simulations, or predictive maintenance in seconds, while using QET, quantum energy teleportation, for efficient power management across vehicle fleets. Broader ripple effects. Technological democratization, quantum tech shifts from elite labs, e.g., IBM, Google, to consumer hardware, slashing costs from millions to watts per device. Energy and sustainability, reduces global data center power draw, currently 2% of electricity, by 90% plus, aligning with net zero goals. Security revolution. On-device QKD renders classical cyber attacks obsolete, but raises risks of quantum-enabled threats, e.g., breaking RSA encryption. AI and consciousness. Sarfatti envisions post-quantum AI with non-local entanglement mimicking qualia, potentially accelerating AGI but sparking debates on machine sentience and regulation. Geopolitical ties. Sarfatti links it to a rare earths war between China, 90% of global supply, and the USA, as YIG/spintronic materials rely on rare earths like yttrium. Success could spur domestic mining, e.g., US mountain pass, or alternatives like ferrite magnets, reducing supply chain vulnerabilities. Challenges include fabrication scalability, e.g., nanoscale skyrmion stability, and noise from real-world environments, with prototypes possibly viable in 2 to 5 years if funded. Economic implications for mobile room temperature quantum computers. If commercialized by 2030 to 2035, this technology could ignite a quantum boom, expanding McKinsey's $2 trillion annual quantum market estimate by 2-3x through mass adoption. It would amplify productivity via ubiquitous computation, but disrupt incumbents and exacerbate inequalities. Below is a table summarizing sector-specific impacts, based on projected disruptions from sources like McKinsey and Sarfatti's analyses. Sector. Key impacts. Estimated value creation, annual by 2035. Winners/losers. Consumer electronics. On-device quantum AI for intuitive apps, e.g., real-time AR/VR rendering, seamless iPhone/Tesla integration. $800B-$1.2T, edge computing market triples. Apple, Tesla, 40 to 60% share, legacy chipmakers, e.g., Intel, obsolete. Healthcare/pharma. Instant protein folding/genomic analysis on mobiles, accelerated drug discovery, hours versus years. $450 billion to $700 billion, R&D costs drop 30 to 50%. Innovators, Pfizer, CRISPR firms, traditional labs displaced. Finance/banking. Fraud detection and portfolio optimization in real time, QKD secured telepathic interstellar trading, per Sarfatti's extensions. $300 billion to $500 billion, trading efficiency plus 10x. Fintech, e.g., quantum hedge funds, banks slow to adopt face breaches. Automotive/transport. Quantum route optimization in EVs, fleet-wide QET for energy sharing. $200 billion to $400 billion, autonomy boosts GDP 15%. Tesla, Waymo, fossil fuel giants sidelined. Energy/resources. Rare earth demand surges, YIG dependency, but QET enables lossless grids, US-China tensions escalate. $150 billion to $300 billion, efficiency gains. US miners, e.g., MP Materials, China loses monopoly leverage. Defense/security. Portable quantum sensors for anomaly detection, unbreakable calms in drones. $100 billion to $250 billion, cyber defense market. DARPA-backed firms, vulnerable nation-states. Global economy, net. Trillions in GDP uplift via productivity, job shifts, e.g., 20% coding automation, inequality if access uneven. $2.5T-$4T total. Tech hubs, Silicon Valley, Shenzhen, developing nations lag without subsidies. Macroeconomic shifts. Growth acceleration, quantum edge computing could add 1 to 2% to annual global GDP growth, rivaling the Internet's impact, by solving intractable problems, e.g., climate modeling on phones. Disruption and inequality. Early adopters, U.S./China tech giants, dominate, potentially widening the north-south divide, requires policies like universal access subsidies. Supply chain wars, heighten US-China rivalry over rare earths could inflate costs 20 to 50% short-term, but spur diversification, e.g., recycled magnets. Labor markets, automates 10 to 20% of white-collar jobs, e.g., logistics, finance, but creates demand for quantum engineers, millions of roles. Investment boom, venture capital floods in, $500 billion plus by 2030, with Sarfatti's patent positioning indie innovators against big tech. In summary, confirmation would herald a portable quantum era, transforming devices into supercomputers and economies into hyper-efficient networks, but only if ethical, equitable deployment tempers the risks. Sarfatti's work, if validated, could indeed change everything, from your pocket to global power balances.